In this video, I'm going to share how to deduce the positions of an element in the periodic table given the electronic configurations of an element, and how to write the electronic configurations of an element given the period and also group of an element. If we have been given the electronic configurations of an element, how do we determine the positions of the element in the periodic tables? So basically, to determine the positions of the element in the periodic table, we just need to follow through 4 steps. Step number 1, we determine the block of the element first. Step number 2, we underline or circle the valence electronic configuration. Then in step number 3, we determine the period of the element, and step number 4, we then determine the group of the element. Example 1 is the electronic configurations of an element. To determine the positions of this element in the periodic table, first we need to determine the block of this element. We can see that the last electron goes into the S subshell. Therefore, this element is S block element. And we know that for S block element, it must be either group 1 or group 2 element. For group 1 element, the valence electronic configuration is NS1 because group 1 element consists of 1 valence electron. And for group 2 element consists of 2 valence electron, and therefore the valence electronic configuration is NS2. With that, then we can circle the valence electronic configurations of this element, which is 5s2. From the valence electronic configuration, we know that the highest principal quantum number for this element is 5. Therefore, this element consists of 5 shells filled with electrons, and therefore it is a period 5 element. And this element consists of 2 valence electrons. And therefore, it is group 2 element. Example 2 is the electronic configurations of another element. To determine the positions of this element in the periodic table, first we need to determine the block of the element. So the last electron for this element go into the D subshell. Therefore, this element is the D block element. So for D block element, it starts with group 3 until group 12. So for group 3 consists of 3 valence electrons, and the valence electronic configuration is NS2, N-1, D1. So 2 valence electrons go into the S subshell and another one go into the D subshell. And for group 12 consists of 12 valence electrons, and the 2 valence electrons go into the S subshell, and another 10 electrons go into the D subshell. With that, we then can circle or underline the valence electronic configuration of this element, which is 4s2, 3d3. From the valence electronic configuration, we can see that the highest principal quantum number for this element is 4. Therefore, this element consists of 4 shells filled with electrons, and therefore is a period 4 element. And then this element consists of 5 valence electrons, and therefore it is a group 5 element. Example 3 is the electronic configurations of another element. So how to determine the positions of this element in the periodic table? Again, step number 1, we determine the block of the element. So for this element, the last electron goes into P subshell. Therefore, this element is a P block element. And for the P block element, it starts from group 13 until group 18. So group 13, 3 valence electron. So 2 electrons go into the S subshell and 1 electron go into the P subshell. For group 18, 8 valence electron, 2 electrons go into the S subshell and another 6 electrons go into the P subshell. With that, then we can underline or circle the valence electronic configuration for this element. And for this element, the valence electronic configuration therefore is 4s2, 4p2. After underlining the valence electronic configuration, we can see that the highest principal quantum number for this element is 4. Therefore, this element consists of 4 shells filled with electron, and therefore is a period 4 element. And this element consists of total 4 valence electron, and therefore it is a group 14 element. If we have been given period and the group, how do we write the electronic configurations of an element? To do this, first we need to write the valence electronic configurations of the element. To write the valence electronic configuration, first we need to look at the period, because period will tell us how many shells filled with electron, and therefore will tell us what is the highest principal quantum number for this element. For this element, it is in period 4, therefore the highest principal quantum number is 4, and therefore the valence electronic configuration should start with 4. And then we look at the group. So this is group 2 element, so group 2 belongs to S block, and therefore the last electron should go into the S subshell. Therefore, the valence electronic configuration should be 4s. Indicates that the last electron go into the S subshell. And this is group 2 elements, so means that this element consists of 2 valence electron, and therefore the valence electronic configuration should be 4s superscript 2, indicating 2 valence electron. With the valence electronic configuration, then we can write the electronic configuration of the element. To write the electronic configuration, we must start with the lowest energy orbital, 1s. 1 orbital, maximum 2 electron, followed by 2s2, 2p6, 3s2, 3p6, and end with the valence electronic configuration, 4s2. So this is the electronic configuration for element L. So this is another element. So how should we write the electronic configurations for this element, given that this element is in period 4 and group 8? To write the electronic configuration, again, we need to start with valence electronic configuration for this element. To write the valence electronic configuration, first we need to look at the period. For this element, it is a period 4 element, so this indicates that the highest principal quantum number for this element is 4, since it has 4 shells filled with electron. So 4. And this element is in group 8, so indicate that it is a D block element and it consists of 8 valence electrons. For D block element, we know that the first 2 electrons must be put in S subshell, and the remaining 6 electrons will go to the D subshell. Therefore, the valence electronic configuration for this element is 4s2, 3d6. With the valence electronic configuration, then we can write the electronic configuration for element M. To write the electronic configuration, again, we need to start with the lowest energy orbital, 1s. 1 orbital, maximum 2 electron, followed by 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Again, we need to end with the valence electronic configurations of the element. This is another element, element N, in period 4, group 16. How do we write the electronic configurations of this element? So again, first we start with valence electronic configuration. So this element is in period 4. Therefore, its highest principal quantum number is 4. So the valence electronic configuration therefore should start with 4. And this element is in group 16, therefore it is a p block element and consists of 6 valence electrons. And for p block element with 6 valence electrons, we know that first 2 electrons must go into the s subshell and the remaining 4 go into the p subshell. Therefore, the valence electronic configuration for element N is 4s2, 4p4. With the valence electronic configuration, then we can write the electronic configuration for N as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, follow the alpha principle, and then 4p4. We must end with the valence electronic configuration of the element.